Hello everyone, welcome to your Project 3 answer section. So for this project, I found some data from Kaggle on NHL game data. I looked at goalie statistics in this set and looked at the information that they had there. So they have information like per game and per player, per team, so on and so forth. A bunch of statistics about that goalie and their game. Okay, like how many shots there were, how many saves they made, how many power play shots, as well as losses and wins. So what I did was I took all of the statistics that are like, goals, assists, so on and so forth as my data, and my X basically, and the decision as my target for my support when I did a support vector machine. So the first thing I did is I downloaded the data. We imported our packages here. I had to do this from pandas import all because I needed to use. Actually, I don't think I need that anymore, so we can remove that. Took this data, turned it into a pandas data frame. I got my X, which was all of the variables that I wanted to train it on, and my Y, which was the target label. I then converted my target label from W's and L's to ones and zeros. So this is a list comprehension with an if and else statement. So basically how this works is like we got the if statement here, and then the output here, and then the else statement's output is here. So I'm saying if it's W, give it a 1, otherwise it's 0 for L. I then only used about 2,000 rows for testing data, and that's because I wanted to, using all 16,000 rows would make this not run on my computer. Okay, so I then made test data for Y. So I also made training data, obviously, which was the first 2,000 rows, and then my test data was going to be 200 other rows that it was going to test on. Okay, so you see here I go from 0 to 2,000 for training, 0 to 2,000 for scoring, and then I pass in our test here. So first I just did a regular linear kernel, but then I did basically what we did in our chapter 10 problem set. But then I also looked at a sigmoid kernel to see if the accuracy would be different. And lo and behold, our sigmoid kernel was 20% worse than our linear kernel, and that kind of makes sense considering that we were looking at trying to get a support vector machine to discriminate between two categories. We wanted to draw like a straight line between the two. So it kind of makes sense that the linear kernel would do a little bit better in this case. But sigmoid kernels, learn what those are and how they work. That was my attempt at doing some parameter tuning or parameter estimation, seeing if different kernels are doing anything to our analysis, and then doing a comparison of the linear kernel to the sigmoid kernel is the other way of dealing with the requirements of this task. Okay guys, so thank you very much and have a great one.